All right, so back again. This one is on the alternating series bound. So the last video you saw talked about the Lagrangian error. This is basically an easier and better estimate for the error, but it's only useful if you have an alternating series. So our example, I think a good example of the alternating series bound would be using sine of x. So let's say, so f of x equals sine x. So let's find the Taylor polynomial. So let's find the Taylor polynomial out to order 4, since it's easy, right? Taylor polynomial of order 4. Which means we have to go out to the 4th degree, right? This is one that we've actually already done, but let's just do it again. We'll center this again at centered at 0. Okay, so first we need to figure out, well, what is f of 0? Well, sine of 0 is in fact 0. Then f prime of 0 is, well, the derivative of sine is cosine of 0, which cosine of 0 is 1. F double prime of 0 is going to be negative sine of 0, which is 0. F triple prime of 0 is in fact now negative cosine of 0, which is negative 1. And actually, so this will be the 4th order, by the way, because note that the 4th one is in fact just 0. But let's also do the 5th derivative. So the 4th derivative, by the way, is going to be sine of 0. And so then the 5th derivative is cosine of 0, which brings us back to 1. And so we notice our Taylor polynomial of order 4, which happens to actually be order 3, just by default, is p of x equals 0, then plus 0 plus 1x, so just x, over 1. Very good. Then we're going to get 0x squared, so then we're going to have minus x cubed over 3 factorial, or 6, and then that's your 0. So our polynomial of order 4, order 3, let's just call it order 3, is x minus x cubed over 3 factorial. Now, the deal is that since this thing is alternating, we know it's going to be alternating, we've done this problem before. Since this thing is going to be alternating, what we can do is we understand from alternating series that an alternating series converges as long as the terms are getting smaller. So as long as these terms are getting smaller, we're good. So let's, so I want to know, how close? So let's see, let's find the upper bound of the error for p of x, estimating f of x, right? Estimating f of x. Let's say at x equals, we'll do something simple like 1/2. So in our Lagrangian, what we would have done is we would have said, well, what is the, so our next function, our 5th degree is cosine, right? And we would have asked ourselves, what is the highest, what is the maximum value of cosine in between 0 and 1/2? But in this case, we basically don't have to. Since this is an alternating series, all we have to do is consider the next term. And so our alternating series error is simply, our alternating series error is simply x to the 5th over 5 factorial. That's it. What is x? X is 1/2. And so this thing says, well, we will actually be within, so that's 1/2 to the 5th. So really it's going to be 1 over 5 factorial times 2 to the 5th. Let's see what that actually comes out to be. We'll get this guy in here. Okay, what does this come out to be? Well, go to math. Oh, hold on, quit. 5, then math. Probability gives us our factorial, which is 4, times 2 to the power of 5. So we're saying we're going to be within 1 over 3,840. Okay, well, let's try it out and see what happens. So, what is cosine of 1/2? And then we'll put it into our polynomial, which our polynomial is 1/2 minus 1/2 cubed over 3 factorial. So we think we are going to be within 1 over 3,840. So let's check that out. Again, let's make sure my mode is in radian mode, just to be careful. We got it. So cosine of 1/2 minus, then inside we're going to have 1/2 minus, okay, we're going to do 0.5 cubed divided by 3 factorial, which is 6. There we go. That doesn't make any sense. Great. That's not good. Oh, clear. Oh, it's sine x. The function sine x. Wow, that's bad. I'm gonna have to edit this one. All right. Whoops. Sine of 1/2. There we go. That's good. We'll go back. Sine of 1/2. Okay, that looks way better. All right. 1 divided by 3,840 now. So there you go. Hit enter. And we notice that this is in fact larger than that. So that's good. All right, sorry about that. So just in case I plugged in, just in case you didn't notice that, I plugged in f of x being cosine. But remember at the very beginning, f of x was sine. And we're good. Okay. So that's the alternating series bound. You can only use this bound when you are dealing with an alternating series. Otherwise, you are stuck with the Lagrangian error. Thanks.